Hello there. This is just a little video introducing the idea of graphing lines, or as I've subtitled it there, what is a graph anyways? And here's the reason I'm making this video, because very often students get to this chapter where the first time they're introduced to this idea of graphing lines, and they work their way through, and at some point, partway through the chapter, or sometimes even at the very end of the chapter, they get a hold of me and they say something like, um, yeah, okay, I can follow all the steps. I can get all the right answers. There was some air quotes there. Um, and I can do all the stuff. I just don't feel like I have a clue what any of this actually means. What is a line? I just feel like I'm following random processes, drawing random pictures. What does this all mean? Um, the other thing that often happens is people get to a certain point in the chapter and they say, I can see all the math steps that the examples are doing, and they all make sense to me, but it seems like they're just picking any numbers they want. How can you just pick any number you want? Won't every student get different answers if we all just pick whatever numbers we want? Um, and so I'm making this video to try to address those two things that very often come up. So the quick answer to that question there, what is a graph, is that a graph is the answer to an equation when there are two unknown variables instead of just one. And I mean that literally. The graph, it isn't this random other picture we draw. It is the answer to that type of an equation. Now let me show you what I mean. So let's go back to an equation where there's just one variable. So something like that. So there's an x. We don't know what x is. We want to figure out what the value of x is that will make that equation true. I've picked a pretty simple one here, so we don't need to do a whole bunch of complicated equation solving to see that x equals 7 is the number that's going to make that true, right? If you stick a 7 in for x, 7 plus 3 is 10, you get a true statement. If you stick anything else in for x, if you stick an 8 in for x, you get 8 plus 3 equals 10. 8 plus 3 is not equal to 10. If you stick 1,000 in for x, you get 1,000 plus 3 is 10. That's not true either, because 1,000 plus 3 is not 10. Only 7 will make that equation true. 7 plus 3 is 10, so 7 is the answer. X equals 7 is the answer. Now let's step that up and imagine an equation where there's two things we don't know. We're just going to call them x and y, but they could be anything. So there we have a very similar equation to the last one, except instead of x plus 3 equals 10 with one unknown, I have x plus y equals 10 with two unknowns. And since we just did that last question, you might think to yourself, oh yeah, well, I remember 7 and 3 made that true, right? If I stick in a 7 for x and a 3 for y, I get a statement that says 7 plus 3 equals 10, which is a true statement. But you've probably already also recognized that that's not the only answer, because, hey, I could stick in x equals 5 and y equals 5, and that works too. 5 plus 5 is 10. Or I could stick in x equals 2 and y equals 8. That works. 2 plus 8 is 10. Who said that one of the variables couldn't be 0? Why not? 10 plus 0 is 10, so x equals 10 and y equals 0 makes the equation true. Now this is getting a little awkward, listing all of these like this. How about we try something a little different? What if we tried putting them in a table? That might help a little bit. And so here I'm going to list in my table every pair of x and y that, when put together into this equation, give you a true statement. There's the ones we did already. These are all solutions to the equation. 7 plus 3 is 10, 5 plus 5 is 10, 2 plus 8 is 10, 10 plus 0 is 10. What if we reverse those? Because that 0 is a pretty easy one to think about, right? If you let one of them, if you think of what happens if y is 0, then x is obviously 10. 10 plus 0 makes 10. What if we swap them around? 0 plus 10 makes 10 as well. So far, all of the numbers we've chosen have been whole numbers. Who said they had to be whole numbers? Nobody said they had to be whole numbers. How about 8.5 plus 1.5? That adds up to 10. So if you stick x equals 8.5 and y equals 1.5, you get a true statement. Or fractions. If you add up 5 1/3 and 4 2/3, you get 10. The numbers could get really ugly like that. You can double check that if you want, and you'll see that those two numbers do add up to 10. So that is another solution to the equation. It's another pair of x and y that makes the left side equal the right side. So far, they're all positive numbers or zeros. Any reason they can't be negative? No. -2 plus 12 adds up to 10. Or really, really big numbers, 4,235 plus negative 4,225 adds up to 10. So that is another solution. So look at all those pairs that we have. And by now, I hope you've realized I could just keep on going all day long here, coming up with pairs of numbers that add up to 10, and therefore make a solution to the equation. There are an infinite number of XY pairs that make that equation true. So at some point, somebody had the idea. They thought, well, what about this graphing stuff we do where we can put points on an XY graph? What if we took all those pairs we have so far that add up to 10, that therefore make the equation true? What would happen if we plotted those on a graph? And there you see I've put most of them on there. I had trouble making the fractions on the graphing program I was using, so I just didn't bother with that one there. And this one here is obviously way too big to be on this particular scale, but it's down there somewhere way over to the right and way down. And look, when you look carefully at all these pairs of numbers that make x plus y equals 10 true, you notice that they all fall on a straight line. And even, well, here, you know what, this 5 1/3, 4 2/3, even though I didn't actually plot it on there, there it is, 5 1/3 for x, then straight up to 4 2/3 for y. That would have been a tough one to put in exactly the right place, but there it is, it's on the line. Even numbers that we didn't come up with are on this line. So for example, 1 plus 9 is 10, right? So x equals 1, y equals 9, right there. And look at that. That is also on the line, even though it's not one of the ones that we came up with in advance. So we can erase all those numbers that we put on. And what we have here is we have a picture that shows every single XY pair that makes the equation true. Now, you might comment, it doesn't show them all because, you know, we run out of graph down here, but we could zoom out and see more of this picture. And this line would keep on going forever down here and forever up here, and it would show all the XY pairs that add up to 10. There's the phone. Hopefully somebody else will get that today. Okay, so carrying on, that means that this picture, which we call a graph, is the answer to the equation x plus y equals 10. I'm just going to drive this home one more time here. Go back to an equation with one variable, x plus 3 equals 10. What is the answer? X equals 7, because that is the only value in the universe that makes the left side equal to the right side. But when your equation has two variables, two unknowns, there are an infinite number of solutions that make the left equal the right, and we show those on a graph. That is the answer to that equation. And this works both ways. So let's go forwards and backwards. Any point that makes the equation true is on the graph. So for instance, just picked one at random there, 3.7 plus 6.3 equals 10. So x equals 3.7 and y equals 6.3 should be on the graph. Yeah, there it is. Would have been a hard one to graph, but it is on the graph. So any equation that makes any xy pair that makes the equation true is on the graph. Turn that around. Any point that is on the graph, how about right there is a point on the graph, right? And that is when x equals -1 and y equals 11. That point should make the equation true. Sure enough, it does. Any point on the graph makes the equation true. Any point that makes the equation true is on the graph. Okay, so what do we got so far? When an equation has two variables, the answer can be represented with a picture showing all of the xy pairs that make the equation true. Now, we are lazy. What is the smallest amount of work we can possibly do in order to draw that picture? Because I just found like 10 points. I don't want to find 10 points. Well, if we know that it's a line, and there will be other types of graphs, by the way, in future math courses that make curvy shapes. They're not all lines, but this particular type of an equation will always make a line. Then all we need to do is find 2 points, because with 2 points, if you imagine you're doing this by hand, you could pick up a ruler and draw a straight line through those 2 points, and you have your graph. So just to drive this home, there's the equation we've already graphed by finding a whole bunch of xy pairs, but let's just say we had found 2 of them. We were like, oh, hey, let's see, 7 plus 3 is 10, yeah. 0 plus 10 is 10, yeah, perfect. Okay, there's 2 xy pairs that make the equation true. Draw just those 2 points on the graph and pick up a ruler, draw a straight line right through them, and there you have the graph that we already drew without finding a whole bunch of points to do it. Okay, I think we're going to try a few here now. So yes, so what we have figured out so far is in order to draw the graph of a linear equation, we just need to find any 2 points, that's xy pairs, that make the equation true. So let's try and draw this graph. I've started out pretty simple. I'm going to do 3 examples here. If you watch this first one and think, oh, that's so easy, great. But I highly recommend you watch the second and third example as well, because sometimes a few little tricks come up that you have to work around in order to find those points. So let's do a little table of values, and I'm going to try to find 2 xy pairs that make that equation true. And I think, all right, what number should I pick for x? Well, I mean, I could pick anything I want. I could pick something really complicated. I could pick 5.73194 and then figure out what y goes with it, but that would be silly. I could pick 11 4/7, but why would I do that when I could pick something easy? How about 0? And here's the place where people say, wait, how can you just pick anything you want? Because everyone will get a different answer. Everyone will get a different y value out, sure, if they all pick a different x, but they will get an xy pair that makes the equation true. That xy pair will be on the line, so it doesn't matter which 2 pairs you get, right? So you might as well pick an easy number. So I'm going to start with x equals 0. I'm going to plug that in there to the equation, so you can see I replaced the x with a 0. Now I'm just going to work out what y is. Y is 3. So there is 1 pair that makes the equation true. Part of what makes this first example a little extra easy is that you see y is isolated, right? So you just plug in an x, calculate the y. But if the x and the y weren't, if it wasn't isolated like that, there would be a few more steps. You'd have to go back to your equation solving, and you'll see that in the next example. So there's 1 pair that makes the equation true. Let's pick another value of x to find another pair. I could pick 14, or I could pick 2004, or I could pick something really easy like 1. And again, whatever you pick, you'll get a different number out for y, but you'll have a pair that is on the line. So stick that 1 in. 2 times 1 is 2. 2 plus 3 is 5. And there we have a second point when x is 1 and y is 5. It makes the equation true. Makes the left side equal the right side. You can always double check, right? 2 times 1 is 2, plus 3 is 5. So 5, when x is 1 and y is 5, you get a statement that says 5 equals 5. Perfect, a true statement. Okay, so we got ourselves 2 points there. I think I'm going to make one of them red and one of them blue and put those on the graph. So the red one and the blue one, 0, 3, and 1, 5. And now draw the straight line that goes through those 2 points. And voila, you have a picture which shows all the xy pairs that make the equation true. Not just the 2 that we found, but any other pair. Like up here, when x is 2 and y is 7 apparently makes the equation true as well, right? Let's take a look at that, because so here we chose 0 and 1 and got the y's that go with them, 3 and 5. But what if we had chosen something else? What if we had chosen x equals 2? Put it into the equation. 2 times 2 is 4, plus 3 is 7. There's another pair, right? There it is right there, 2, 7. Or what if we had chosen x equals -1? Put in -1, follow the work, pause it if you want to, and follow this through. You get out y equals +1. Or what if we had chosen x equals -2? 2 times -2 is -4. -4 plus 3 is -1, so there's that pair. And we can pop all those points on the graph. There they are. They are all on the same line, so it doesn't matter which two you chose. We chose this red and blue one here and drew the line, but you could have chosen any two of those 5 points. You could have chosen -1, 1, and 2, 7. Draw on the line, you would get the same line. It would still go through the red and blue points, right? It doesn't matter what values you choose because you are finding the pair that goes with it. So choose easy numbers is lesson number 1. Let's do another one. So you see here y, in this example, y is not isolated. So we're going to have to do a bit of equation solving. Well, starting with 0 seemed to work out pretty good last time. So let's try that again. Let's stick in x equals 0, like so. So you can see I've taken the equation, 3y minus 2x equals 12. I've replaced the x with a 0. 2 times 0 is just 0, so that works out nicely. On the left side, we get 3y minus 0, so that's just 3y. On the right side, of course, we still have a 12. How do I solve this equation? By dividing both sides by 3, like so that the 3's cancel out, and I end up with y equals 12 divided by 3, which is 4. There is a pair that makes the equation true when x is 0 and y is 4. And we can always double check it. Put in y equals 4, x equals 0. You get 3 times 4 is 12. Minus 2 times 0 is 0. 12 minus 0 is 12. Yep. Okay, let's find another one. Last time, using x equals 1 worked pretty good. Why don't we try that again? So we're going to stick in x equals 1. 2 times 1 is 2, so not quite so simple as last time, but still not bad so far. I'm going to solve that equation by adding 2 to both sides, which gives me 3y equals 14. Divide both sides by 3 to get rid of the 3, and oh, this is not looking so nice. 14 over 3 doesn't divide nicely. That is as a mixed number, that is 4 2/3. Now that is a legitimate point. I'm going to put it in the table for a second. When x is 1 and y is 4 2/3, if you want to check that out, you can pause and work out the math. That will make the left side equal to 12. So the left side equals the right side. But how are we going to graph that point? X equals 1 is easy enough, but then you're going to go up to y equals 4 2/3. You're going to be guessing, right? Where exactly does 4 2/3 land? That, when we get fractions, that is going to be too hard to create an accurate graph. And so what we want to do is scrap that, even though it's true. We want to scrap it. Pardon me. And we want to try some other numbers until we can find a pair, if at all possible, that has whole numbers. If you try x equals 2, you'll find you get another fraction. But if you fiddle around a little bit, you might eventually find that with x equals 3, it does work out nicely. So plug in x equals 3. 2 times 3 is 6. Add 6 to both sides. 3y equals 18. Divide both sides by 3. Y equals 18 over 3, which is a nice whole number, 6. So if you're wondering, well, how did you come up with the 3? Again, it's sometimes, in some questions, it's going to take a little bit of fiddling around and trying a few options. The more you do, the quicker you'll get at seeing the patterns about what can I do to make this, particular one work out to whole numbers. But every once in a while, you might just have to try a few until one works. If you really don't like that, don't worry. Later on in the chapter, we develop some more methods for graphing. We develop some, I was going to say shortcuts. They're often actually not shorter. Often actually take longer than just quickly finding 2 points. But they will work in any situation, which is nice. So there we got our 2 points, 0, 4 and 3, 6. Let's plop those onto right. Actually, I want to find another one here. I want to show you something different, because although you could have fiddled around with a bunch of examples and found that 3, 6, those zeros are really, really easy to use, right? When you put in a 0, it makes a whole piece disappear. We put in x equals 0. There's no reason we can't start with the y and find the x. So instead of starting with the x and finding the y that goes with it, we could start with the y and find the x that goes with it. So you see here, instead of finding that 3, 6, another option would have been plug in y equals 0. 3 times 0 is 0, so that just goes away. So all we got left is negative 2x equals 12 without having to do that extra step of equation solving. Divide both sides by negative 2, and you get x equals negative 6. So look at that. That was probably easier than finding this one for several reasons. One, because 0 is easy. 2, because you didn't have to test a bunch and find fractions. Now, sometimes I should say that you'll plug in the 0 and end up with a fraction, in which case you got to go hunting for another point. But I would recommend, for an equation like this, starting with x equals 0 and then y equals 0 as your 2 points is a great way to go. So we actually got 3 pairs there we could use. We can use any 2 of them, or, I mean, since we have all 3, I guess you could put all 3 on the graph, make sure they line up. But just for the sake of argument, let's say we hadn't bothered to trial and error and find that 3, 6 point. Let's say we had just done the x equals 0 and the y equals 0. So we found the point 0, 4 and negative 6, 0. There they are. Draw a line through them. And there you have the picture of all xy pairs that make the equation true. And remember that other point we found, 3, 6? Well, sure enough, it's on there as well, right? 3, 6 on the line. Even though we didn't use it in this particular case to draw the line, it is on the line. Every xy pair that makes the equation true is on the graph. And oh yeah, remember we found that other point too, the one we didn't use. When we stuck in x equals 1, we got y equals 4 and 2/3, remember? Well, it's on the graph too, right? X equals 1, up 1, 2, 3, 4, and 2/3 of the way to 5. There is the point 1, 4 and 2/3. It makes the equation true, so it's on the graph. It is just hard to graph accurately, so we don't use it. We try and find sure, definite points, especially if you're using something like MyOpenMath or MyMathLab online. You need to get those points exactly on. Otherwise, you won't get the mark for drawing it. So you really need to find those nice whole number points that you can plot in order to do those graphs. All right, let's wipe that off and do one last example. Notice this one has a fraction in it right off the bat, y equals 1/3 x minus 1. So that's a downside. It makes this one a little harder. Upside is you do notice this one's back to one where we have the y isolated, which makes things a little easier. Well, let's try that x equals 0. That always seems to be a good starting place. 1/3 times 0. Sorry, there it is. 1/3 times 0 minus 1, sticking the x as 0 in for the x. That just becomes 0 minus 1. And there's our first point. That was easy. X equals 0, y equals negative 1. What should we try next? Well, again, and I mean, you could try y equals 0, but I would be inclined not to on this question, because then you're going to have to solve for x, right? Why not? It might actually be easy, but I'd be more inclined to try another x value, which I can just plug in. X equals 1. So let's plug that in. But you may already see that we're going to have a problem here. Remember, when you multiply a fraction by a whole number, you have to rewrite that whole number as a fraction. So you can multiply the tops and multiply the bottoms. You get a third minus 1, and if you did a bit of fraction work, you would turn that 1 into 3 over 3 and subtract to get negative 2/3. So that is a true point. It will be on the graph, and we'll look for it after we draw the graph just to show you that, but that is not a good one to use in order to create our graph. So let's try again. Instead of 1, let's try another number. Now, what you may notice is that what caused the fraction there was that we're dividing by 3 here, right? We have an over 3. So if we could put something in for x that is divisible by 3, that would make that not turn into a fraction. Probably the easiest to use would be x equals 3, but just for argument, I've just picked something else. I picked 6, which is divisible by 3, and look what happens. A third times 6 minus 1. Remember, again, the 6 has to become 6 over 1. People are, even after they've learned all their fraction work, are still sometimes tempted to multiply that 6 into the top and the bottom. That is incorrect, right? Because remember, 6 actually means 6 over 1, not 6 over 6. So we multiply the tops and multiply the bottoms. So 1 times 6 is 6, 3 times 1 is 3. 6 divided by 3 is 2. So we have 2 minus 1, which is equal to 1. There is a nice point for us as well. If we had stuck in x equals 3, I think we would have got 0, 3, 0. So we'll look for that because that's going to be on the graph as well. All right, so let's take a look here. There's our 2 points, 0, negative 1, and 6, 1, that make the equation true. Put them on the graph, 0, negative 1, and 6, 1. Draw a line through, and there you have the picture that is the answer to that equation. It shows all xy pairs that make the equation true. You remember I did notice that if we had stuck in x equals 3, we would have got y equals 0. There's that point there. That would have worked just as well. Also, the other point that we got, 1, negative 2/3. Well, let's see. X equals 1, y equals negative 2/3. There it is. On the graph, just would not have been a good one for us to use in order to draw the picture. Other ones that looked like they would have worked well would have been using x equals negative 3, and you would have got out y equals negative 2. Or x equals negative 6, and you would have got out y equals negative 2. Anything bigger than that would have been off this graph, which would be fine. You just have to create your graph accordingly. All right, so I think that's it. Yeah, so when an equation has one variable, there is an answer for the variable. When an equation has 2 variables, there are an infinite number of pairs that are answers, solutions, and therefore the way to show the answer is to draw a picture, the graph of, in this case, straight lines. And again, later on, you will run into all kinds of crazy shapes by putting roots and powers and all kinds of stuff like that into the equations. But for now, all you're going to see is straight lines. Hope that helps. Have a great day.